Hello there and welcome again. My name is Michael Fudge and this is another episode of Learning to Program in Java. We're at Lesson 9. This picks up where the previous lesson left off. In Lesson 8 we talked about the if-else statement. This lesson we'll take another look at the if-else statement, but look at how you can nest it to create an advanced decision logic. We'll also take a look at the switch statement and we'll discuss how you can create your own data types using enums. On the agenda for today, first we'll look at the if-else pattern, what's called the if-else ladder. Then we'll look at the switch statement and finally we'll finish up with enumerations. And of course I have examples of all of these. Let's start out with nested if-else. Sometimes you need to branch based on a series of Boolean expressions rather than just a single Boolean expression. Last week we learned that with if-else you can test one Boolean expression, and if it was true you can execute a series of statements, or false, execute a different series of statements. The problem solved with a nested if-else is when you need to test more than one Boolean expression. So for example, on the code on the right, I might test this expression, and if it were true, I might execute this statement. If that particular expression were false, I would then test this expression, and if it were true, I would execute this statement. However, if expression 2 were false, I would then test this expression, and if it were true, execute this statement. And then finally, if expression 1, expression 2, and expression 3 were all false, I would then execute the else clause. So you can see how this becomes, we call this a if-else ladder. As you can see, the if and the else-if statements form kind of the rungs of the ladder. Another type of branching statement that you can use is called the switch statement. The switch statement is a little different than the if-else statement because while if-else allows you to branch on an expression, the switch statement allows you to branch on the value of an expression. When you're using switch, you're not comparing for true-false. You're actually looking at values such as integers or strings or characters. To give you an example, maybe my switch statement evaluates this expression and the value of it is value 2. So then the switch statement would jump down to this case, execute that statement, and then if I include a break, it will jump out of the other cases and then finish off at the closing brace. If I leave the break in, it will fall through to the next case and then test that case. Typical use cases of the switch statement involve you putting a break after each case. Okay folks, it's time to do a demo. We're going to demo the switch statement and the if-else ladder by doing some very simple logic where we ask the user to enter a number for the month and ask them to enter a number for the day of the month, and then we print out a statement that might say January 31st or February 14th. Let's see it in action. Okay, here I am in our first example, and unlike prior examples where I'll actually type in the program, rather than do that, I think it's better if I run this program and then show you how the switch and if-else ladder work by debugging the program and stepping through it a line at a time. I grabbed this example, which is called switch statement and if-else ladder. I grabbed that example from the GitHub site. And you can see I have 3 methods inside this class, and they're all static because this is the main class. I have one called getMonthName, which you give it a month, like 2, and it returns a month name, like February. Then I have this other method called getDayName, in which you give it a day number such as 3 and it returns 3rd. If you give it 2, 3 in the program, it would print out February 3rd. Let's run the program so you can see how it works. Then let's discuss how these constructs were put together to solve this problem by tracing through it a line at a time. So you can see it says enter month 1 through 12, so I'll enter 2. Enter day of the month 3. And it says that's the 3rd of February. See that? Let's run it one more time. Let's enter 12 and 25. That's the 25th of December. So you can see, depending on the day of the month, it's going to say 1st or 2nd or 3rd or 14th. And then depending on the month, it's going to say January, February, March, April, May, etc. Let's see how they were implemented and then trace through the program a line at a time. So get month name, I use the switch statement because, again, remember, switch takes a look at a value and then branches based on the case of that value. So what I'm saying here is, given your month as an integer, if the month is a 1, do that. If the month is a 2, do that. If the month is a 12, do that. And because I have breaks between these, it doesn't try to fall through and test the other cases, so it doesn't try to run unnecessary code that we don't need. And then this method will return result, which is going to return one of these month names. getDayName is a little more complicated. What you're going to do here is it's going to pass in a number like 3, and then it's going to do a series of if tests to figure out whether it should say st, nd, rnd, or th. For example, if the day ends in a 1, like it's the 1st or the 21st or the 31st, then we want to take that day and add st at the end. Of course, if the day's 11, we don't want to do that, because 11 should be 11th, right? This is kind of complicated logic, and the best way to explain how it works is to kind of trace through it a line at a time. So we'll do that, and we'll also add some watch expressions along the way. Okay, let's get started and run this program by debugging. I'm going to step into it by pressing F7. And now I'm on line 8. And I'm just going to run this with F8 until I enter both of my inputs in. So let's do, I don't know, we'll do 5. And enter day of the month. Let's try 11. And now what I'm going to do is, rather than continue to run it, I'm going to put a breakpoint right here so I can see what's happening. And then I'm going to throw another breakpoint down here. So I've got my breakpoint on line 63, and then my other breakpoint is going to be right there. Alright, so I've got my 2 breakpoints. Let's continue with F8. So now I've jumped into getDayName, and if you remember, I gave it day 11. This first expression says if day doesn't equal 11 and day, when you take the remainder divided by 10, is a 1, right? So both of those conditions need to be true to drop into this case. Let's think about that. The day equals 11, so that's false. And is this true or false? I don't know. So you might be thinking, I'm not smart enough in my head to know if that's true or false or that's true or false. So what you can do, remember, is you can add a watch. You can hover over this, new watch. Let me get rid of this old watch here. Then I can hover over this one and add that as a watch. So day not equal to 11, that's false because the day is 11. Day divided by 10 has a remainder of 1, that's true, but because it's and, they both need to be true for the whole condition to be true. So when I press F8, it's going to skip and go down to the next if. Let me just change my watches right here. So this one says 12, and the remainder is 2. Remainder is 2. Both of these expressions are false. You can see that here. So it's going to skip line 66 and go to line 67. Now it's going to test 3 and 13. Those are both false. So it's going to skip line 68. And it has no choice at this point but to do line 70. And I'm in line 70. So this is day is 11, so it's going to say 11th. Okay, now we're going to jump into get month name, and this is actually a little simpler logic. The month is 5, so I'm going to switch on 5, and I'm going to jump right down here to case 5. Watch this. I'm going to press F8. I jump right down to case 5, which is May, and then break will exit out of the case statement down here, and I can return May. Then when I finish execution, my output says the 11th of May. Let's run it one more time and try a different value. So this time I'm going to enter March 23rd. So I'm in here, 23. So 23 does not equal 11, and 23 doesn't end in a 1, so it's going to skip that. 23 is not 12, and it doesn't end in a 2, so it's going to skip that. 23 is not 13. That's true. And it does end in a 3. So that's true. So if I look at my variables, just to show you, both of these conditions, whoops, both of these conditions are true, which means this entire expression is true, which means it's going to drop down here to line 68. Meaning 23rd. Notice how as soon as I find a condition that's acceptable, the if-else ladder drops me out of the entire block. I don't continue on and test the next condition. That's not how it works. And then I return 23rd. Now, again, get month names a little easier. My month is 3, so I switch on month. I'm going to jump right to 3 in the case, which is March. Then I break. That exits me out. Return result. 23rd of March. To review, the case statement is used to branch on a value. So month is not true or false, it's a value like 1 or 2 or 3 or 4. And I'm merely branching based on the value of that variable month. The if-else ladder is used to branch based on a variety of true-false conditions. So I cannot use the switch statement to implement the same logic for get day name. I have to use the if-else ladder. I could write it as a switch statement, but it would be really messy. I'd have to account for every single possible day of the month. As you saw in the example we just did, we had months, and we had 1 as January, 2 as February, 3 as March. Well, come to find out, there's a much easier way to implement this logic in Java. To do that, we use what's called an enumeration. An enumeration is a custom data type that enables a variable to be set to constants of a predetermined value. Enums are declared like a class. For example, I would say public enum suits, like the suits of a card, and I have clubs, diamonds, hearts, and spades, and then I set what the predetermined values are of those constants. And then what I could do is I can create a variable of type suits and then assign it the value clubs, diamonds, hearts, or spades. I can also print a value of type suits and get the word diamonds or hearts or spades or the value 1 or 0 or 2. Let's do our final example and demonstrate this. Okay, for this example, what I've done is I've created a brand new project, and in there I have a package called enumerations, and in there I have a Java file called enumerations run, and this has my main method in it. I haven't really done much of anything yet. Let me start by making an enumeration. I'll make the most basic enumeration I can. Then, of course, I'll expand it out to be a more useful implementation. So let's get started here. I'm going to go here, new Java class. I'm going to call this direction. There's my empty class, but I'm not going to make it a class. I'm going to make it an enum. And now what I'm going to do is just give it values. North, south, east, and west. Now, I'm done. What did I do, and what does it help me? How does it help me? Let's go back to enumerations run and try some things out. How about this? System out println direction dot north. What does that do? Let's see what that does. It says north. Or how about direction dot south? It says south. You can see in our previous example we had to convert a number like 1 into a string like January. Enumerations kind of do this for us, and that's kind of neat. I could have made a enumeration that said month.January. The question you might have is, what value is south? And can I set it to a meaningful value? And the answer, of course, to that is yes, you can set it to a meaningful value, but you have to do a little more work to do that. So let's go back and modify our direction Java. So the first thing I need to do is I need some place to store what it means to be north, south, east, or west. I'm going to do that with my private variable. And this is going to be a constant. I'm not going to be able to change these values, hence the reason it has final in here. And now what I can do in my enumeration, I can provide actual values. So I could do this. I can say north is 0 degrees and south is 180 degrees and east is 90 degrees and west is 270 degrees. You'll see it's kind of complaining at me, and what it's asking me to do is I need to give it a constructor now so that I can explain how I initialize these variables. So direction int degrees, and the usual this degrees is assigned degrees. And then last but not least, if I want to get the number 180 for south, I need to have some kind of public accessor to do that. So how about a public int degrees return this dot degrees. Now this looks like a lot of alphabet soup, and this is probably one of the complaints about object-oriented programming at times, is it seems like you're writing a lot of code that does nothing. But believe it or not, what I just wrote here does some pretty interesting things. So let's go back to our enumerations run Java and find out what we can do with what we have now. Well, first and foremost, does direction.south still work? Let's just run it. It still says south. But watch what other cool things I can do. I can say direction D gets direction dot north. Then I can say system out printf. How's this? %s is at %d degrees. And let's see what happens when we print out D and D dot degrees. Well, what is D? Well, D is north. And how many degrees are in north? Well, when we run D dot degrees, it's going to return the integer value that's represented by north. North is at 0 degrees. Don't believe me? Let's try one that has a real number. How about direction dot west? West is at 270 degrees. See, enumerations do two things. One, they make your code easier to read, because now this code here, when I use the enumeration, makes a lot of sense. It just says direction.west. I don't have to care that that's 270 degrees. But it also provides usefulness, because I could take that arbitrary value west and then assign it back to some ordinal value that makes sense in context. Like, for example, if I want 1 to be January or 2 to be February, I can then do that. If I want west to be 270 degrees or east to be 90 degrees, I can also do that. So that's how enumerations can save you time and effort as a programmer. What might not be obvious to you is how this works. So let's just kind of digest it one more time together. North 0, south 180. What is that really now doing? It's really calling this. So north degrees are 0, so that when I ask for degrees from north, it gives me 0. That's why it's a final, is I cannot change these values. They get initialized when Java builds the program. There's no way for me to make up some new arbitrary degree in here. For example, if I say direction NE for northeast, I can't say 45. You see, that gives me an error because the data types don't match. I also can't say new direction 45. That doesn't work either because enum types may not be instantiated. You cannot create a new object from an enum. So if I want northeast, the only way for me to have northeast is to add that to my enumeration. Like this. Maybe I want to add northeast 45 degrees. I'm really going to do the math. Southeast would be 135 degrees. Southwest would be 225, and northwest would be 315. Man, I am rusty. Now I've just added, now there's 8 possible values for direction. What you're really doing is you're making a new data type called direction. And ints have tons of different values. You can be 1 or 100 or 1,000 or a -50. My data type direction has 8 values: north, south, east, west, northeast, southeast, southwest, northwest. Just so happens that I have a way to convert that value of southeast to another value that is just a plain old integer. Let's see if this actually works now. So I can say direction NE gets direction dot northeast. And then when I print that, I get, I still get west. West is 270 degrees because I never changed this. So if I say, well, let's be fancy. How's this say? D gets NE. And then it should work. Northeast is at 45 degrees. I really hope this example proves the need for enumerations in programming. Their number one purpose is for you to establish your own data types and then the values that represent the contents of the variables of those data types. By using enumerations, your codes end up being a lot more easy to read and understand, because rather than using a number to represent a value, you can use the real thing, like direction west. Finally, the last benefit of an enumeration is you can just easily say direction west and print it out, and it'll print out the value west. So you don't have to try to figure out how to convert a value to a string to display it. Those are the real big key takeaways from using enumerations. And this concludes our 9th lesson in the Learn to Program in Java series. Hopefully you have a better idea of the difference between the switch statement and the if-else ladder. And hopefully you enjoyed my introduction to enumerations, and you can probably figure out how those will be valuable to use in future lessons. Thank you so much for taking the time to watch these videos. I welcome your questions and comments and feedback on YouTube. We'll see you later. Bye now.